Which of the following has more inertia? A rubber ball and a stone of the same size. Question number one goes to Lavansh.
Um, a stone
Why stone?
because it's heavy.
Yeah, more mass implies more inertia, right? Pritish, now
Yes.
you answer the second part of the same question. Bicycle and a train.
Which which part?
Which has
Second part.
more
Yes,
inertia, bicycle and a train?
Uh, a train.
Because it has more mass and hence more inertia. Yes.
Yes, ma'am.
Okay, Lavansh, a 5 rupee coin and a 1 rupee coin.
Ma'am, both have same.
See, 5 rupee coin is a little heavier than 1 rupee coin, no?
Like, yeah, it's more thick.
Thick and heavy also.
Yes.
I forgot
You forgot what?
the coins
Coins? Okay.
because ma'am, here it's
Hmm.
cents, and we don't use the cents like not much.
Okay. Fine. No, no problem. Now, question number two. Read question number two now.
In the following example, try to identify the number of times the velocity of the ball changes. A football player kicks a football to another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards a player of his own team.
Hmm.
Also identify the agent applying the force in each case.
Mm-hmm.
Mm,
A football player kicks a football to another player. One of his
So,
team
how many
kicks
times
the
velocity of the football is changing?
ball to
two times.
uh, three and four
Three
men.
times.
Four.
Yes, velocity of the football
Oh.
is changing 4 times.
Yes,
Can you
ma'am.
the first time when the football player
The
kicks the
football
football to
player
another player.
kicks a football to another
Towards
player.
another player.
This is the first time it is happening. And second time,
The
Towards the goal.
goalkeeper. Uh,
Towards
second
the goal. Another player kicks the ball towards the goal.
when the
and
player kicks
then
the
ma'am, the
football to the
goalkeeper.
goalkeeper.
Yes, ma'am.
And then
The
Then
goalkeeper
ma'am, the goalkeeper hits the kicks the
kicks
ball.
the ball towards another player of his own team.
goalkeeper stops the ball, collects the football, no? Stops the ball, collects the football, and he kicks it towards
Kicks
the player
towards
of
the
his own team. So four
player
times.
of his own team.
Collects means he stops the football and he kicks it towards the one, and then to the goalkeeper. Goalkeeper stops the ball and then kicks it towards the another player. 4 times the velocity of the ball is changing. Yes. So also identify the agent supplying the force in each case. In the first case, who is supplying the force?
A
The
football player.
footballer.
Football player. In the second case, who is supplying the force?
A
The
football player.
another player.
Another player. Third case,
The
A
goalkeeper.
goalkeeper.
the goalkeeper. And in the fourth case,
The
Uh,
goalkeeper. Nah,
goal.
the football
player.
player. Another football player.
Again, the goalkeeper because goalkeeper is kicking the football to the player, no?
Yes.
Yes.
All right, next question. Explain why some of the leaves may get detached from a tree if you vigorously shake its branch. Trees are, see, the branches
Because
are,
of
hmm?
because of they have inertia and mass.
See, if you vigorously shake the branch of a tree, leaves are, weakly attached to the branch, no?
Yes.
Yes.
And leaves which are weakly attached to the branch fall off due to inertia of rest.
Rest.
Because they are at rest and they are now in motion after we
Because they are
shake it.
firmly attached to the branch and due to inertia of rest, they fall off, right?
Hmm.
They resist the motion and they fall off. Okay, next question. Why do we fall in the forward direction when a bus brakes to stop or fall backwards when it accelerates from rest?
Because of inertia of rest.
We have two questions
Hmm.
here.
Because
Yeah.
of inertia of motion. Because when no, yes,
Yes, ma'am.
rest. Because when the bus is moving, it immediately like stops, and then like um due to inertia of rest, it stops like
There are two
it
questions. So
goes from
ball
motion to
in the
rest.
forward
That's why.
direction when a moving bus brakes to stop. This is the first question. Answer this first. If the bus is initially moving and brakes are applied, then
Yes.
our lower
Then
body
the bus.
comes to rest along with the
Yes.
bus, but our upper
Yes.
body resists the change and upper body is still in the state of motion and it moves in the forward direction.
Yes.
And second part of the same question,
And fall
fall
backwards when it
backwards.
accelerates from rest.
Hmm.
Because in
Because of the
like
inertia of
because of inertia of
motion.
motion, like when the now the bus again goes from rest to motion.
Yes. So when a bus starts suddenly, a lower body moves with the bus, but our upper body resists the change and it moves in backward direction,
Hmm.
opposite to the direction in which the bus is moving. So the two cases and two different inertias here. In the first case, we'll apply inertia of motion.
Rest.
See, it is about moving bus, it breaks to stop.
Yes, yes, yes. Inertia of motion.
And in the second case, we'll apply inertia of
Inertia
rest,
of rest.
right? So we need to explain it properly. Clear?
Yes.
Have you written these answers in the notebook? Example 8.1. A constant force acts on an object of mass 5 kg. So we have an object here and mass of the object is 5 kg. A constant force is acting on this object for a duration of 2 seconds. So for 2 seconds, this force is acting on the object. And because of this force, speed of the object, the velocity of the object is increasing from 3 meter per second to 7 meter per second. So initial velocity is 3 meter per second. U is the initial velocity. V is the final velocity. It is 7 meter per second. Find the magnitude of the applied force. This is what we have to find for a duration of 5 seconds. And what would be the final velocity of the object? This is the question. Final velocity of the object after 5 seconds. How will you do this? So initially, see, we have applied force. When we had applied force, then after 2 seconds, velocity became 7. No, from 3 to 7, it changes. From 3 to 7, right? In 2 seconds.
Yes.
So we can find the acceleration. It's v minus u by t. Rate of change of velocity with time is the acceleration. Put the values here. Final velocity. You know how to do it?
Yes, ma'am.
Okay, please.
Yes, ma'am.
First find the acceleration because force is constant. So acceleration remains constant because mass is also constant. So v is 7, initial velocity is 3, time is 2. So this is 4 upon 2, 2 meter per second square is the acceleration. Now we can find force. Force is equal to, we can apply the second law of motion here, mass into acceleration. So put the values, m is 5, acceleration is 2, so force is 10 Newton. This is for 2 seconds. We're talking about 2 seconds here. Till here we are done. Now, in continuation, we have another thing. See, what if we apply the same force for 5 seconds? See, in 2 seconds, velocity has been changed from 3 to 7. So if we apply the same force for 5 seconds, velocity will change again?
Yes. 7 to 11.
Depends. We need to find out.
In 4 seconds.
Acceleration is constant because force is constant. Because we are applying constant force on the object, hence acceleration is also constant because m is constant. क्योंकि मास भी कांस्टेंट है ना एंड एफ इज इक्वल टू एम ए होता है अगर दो क्वांटिटीज कांस्टेंट होंगी तो थर्ड ऑटोमेटिकली कांस्टेंट होगी राइट
Yes.
So we have our acceleration. So now the velocity is v dash. After 5 seconds, velocity will change again. Now it is v dash. So v dash minus u upon t. Now put the values here and you will get your v dash. So acceleration is 2 meter per second square. Your v dash is, we have to find out, and u is 3, time is 5. Find the answer. Get the answer now.
Okay, ma'am.
Please turn on your camera. So you'll get your v dash.
Ma'am, I have to charge. I can't turn the camera. Ma'am,
Hmm.
I have to charge.
Okay. So v dash is, move this 5 to the other side. It's 5 into 2 plus 3. So 10 plus 3, 13 meter per second is the velocity. After 5 seconds, velocity will change again. This is the final velocity after 5 seconds. And see, the way we have done here, we have used the first equation of motion here. You can see here we have, as in the solution, you can see here that we have something like v is equal to u plus at. This is the first equation of motion we had done in the previous chapter. And in place of a, f by m is written. Okay, so you get ft by m. So you can put the value of f, t and m here. No? So this we have found out using the first equation of motion here. I hope you can hear what I'm saying, Lavansh. Your voice, I think your video is, there is some problem with the internet connection.
I think he left.
Please write the answer. Do the questions first.
Yes.
Okay. Which would require a greater force? Accelerating a 2 kg mass at 5 meter per second square or a 4 kg mass at 2 meter per second square. So we have two different situations. In the first case, mass is 2 kg and acceleration is given to you. In the second case, again, a different mass is given and different acceleration is given, right? So we've got the values here. So M1 is 2 kg, A1 is 5 meter per second square, 2 kg mass at 5 meter per second square, and M2 is 4 kg, and acceleration A2 is given, it is 2 meter per second square. Question is which would require greater force. So for in both the cases, we are going to find the force. How will you find the force? In the first case, we'll write F1. F1 is equal to M1A1, find the force. In the second case, write F2 is equal to M2A2, again find the force in both the cases, right? Multiply the two quantities and you will get your answer. So in the first case, it is 2 into 5, 10 Newton, while in the second case, it is 4 into 2, 8 Newton. So which would require greater force?
Second.
Second one, ma'am.
First one.
First one. It's 10, no?
First, ma'am. Yeah. It's 10 Newton.
Yeah. In the second case, we are getting 8 Newton. Right?
Yes, ma'am.
Write the answer now.
Yes.
See, in the question number 3, we have a motor car here. It is moving with a velocity of 108 kilometer per hour. So we have a car. We have a car and it is moving with initial velocity. And the velocity is given. It is 108 kilometer per hour. See, we can convert this into meter per second. How do we do the conversion? We can multiply it by 5 by 18 and we'll get the answer 5 by 18 into 108 meter per second. So you will get, on solving this, what will you get? See, 3 6 are 18, 3 3s are 9, remainder is 1, 3 6 are 18 again, 6 1s are 6, 6 6 are 36, and you will get 30 meter per second as the initial velocity of the motor car, and it takes 4 seconds to stop. It takes 4 seconds to stop. So what is the final velocity? It stops after some time. After 4 seconds, it stops. So time
Yes,
taken is 4 seconds, and it's because it stops, and therefore we take final velocity as 0 after the brakes are applied. Calculate the force exerted by the brakes on the motor car if its mass along with the passengers is 1000 kg. So we need to find the force, and the mass of the motor car with the passengers is given, it is 1000 kg. Find force. How will you find force? See, we know that force is equal to mass into acceleration, right?
Yes.
Force is mass into acceleration, and acceleration is v minus u by t. And since here you can see the velocity of the car is decreasing, no?
Yes, ma'am.
Yes.
It comes to stop after some time, and therefore we can say the car is decelerating. Decelerating, or we can use the term retarding or decelerating. So you will get your acceleration negative. Acceleration is negative in this case because final velocity is less than the initial velocity, right? So now put the values here and you will get your force. So I'm writing here. Should I write here? Somewhere here?
Yes, ma'am.
Yes,
So
ma'am.
F is equal to M. M is 1000 and
Yes.
V is 0. U is 30. Time is 4. Just put the values and solve. So you'll get 1000 into minus 15 by 2. We can write this as minus 30 by 4 is minus 15 by 2. 2 ones are 2.
Mm.
2 fives are 10. It's 500. 15 fives are 75. 100 with a negative sign Newton. Why is the sign negative?
Because it's decelerating.
Yes, because this force is opposing the motion of the car. This force is against the direction of motion. This force is against the direction in which the car is moving. So therefore, we have a
Hmm.
negative sign here. Whenever acceleration is negative, we'll get a force is negative. Okay. So
Hmm.
negative sign tells us that the force exerted by the brakes is opposite to the direction of motion of the motor car. The direction in which the force has been applied is opposite to the direction of motion of the motor car. This is the reason that we're getting the negative sign here. Okay, now please write the solution. We'll move to the next question then. We have another question here. Question number 4. A force of 5 Newton gives a mass m1 an acceleration of 10 meter per second square. So first, we have a force statement. We have an object here of mass m1, and on applying a force of 5 Newton on this object, acceleration produced is 10 meter per second square. So we can write this force as F1 and acceleration as A1. And we have another object of mass M2. And again, we are applying force. A force of 5 gives a mass and acceleration of this, and a mass M2 and acceleration of 20 meter per second square. So the same force when we apply on another object of mass M2, we get, or it experiences an acceleration of 20 meter per second square. What acceleration would it give if both the masses were tied together? But if we, tie these two masses together, M1 and M2 together, and we apply the same force, 5 Newton, on these objects, then what acceleration will be produced? This is the question. So first we need to find M1 and M2, only then we can do this question, right? How will we do this? Any idea?
M1 and M2.
Hmm?
M1 is 10 meter second
M1 is F by
square.
A. We can write force as 5 Newton every time because it is 5, so we can use F for 5 Newton. This is A1 and this is your A2. So F is M1 A1, no?
Yes.
Ma'am.
So mass into acceleration is force, and therefore mass is force upon acceleration. Put the value. Force is 5 Newton, acceleration is 10 meter per second square, so we'll get half, 0.5 kg. Mass is measured in kilograms. And similarly, we can find M2. So what is the value of M2? It is F by A2. So 5 divided by 20. It's 1 upon 4. Or in decimal, we can write 0.25 kg, no?
Yes.
Yes, ma'am.
Now, because both the masses are tied together, so what is the total mass now? In the third case, m1 plus m2 is the mass, no? We, in place of mass capital M, we can write m1 plus m2. So force in the third case is the given mass into the acceleration. This mass is m1 plus m2. So m1 plus m2 into A is equal to F. Now put the values. F is 5 Newton. M1 is 0.5. M2 is 0.25 into acceleration. So 0.5 plus 0.25 is 0.75, no?
Yes.
0.75 into A. And this implies acceleration is equal to 5 upon 0.75. Now you can solve this. You will get 5 upon into 100 by 75. 25 threes are 75. 25 fours are 100. So acceleration is
Yes.
20 by 3 meter per second square, or you can write your answer in decimal. It is 3 6 are 18,
18 point
6.67
zero
meter per second square.
zero 6.6.
666 you will get now, so we can round it off and we'll get 6.67 meter per second. Right?
Yes.
Yes. In the next question we have, you can see we have a velocity time graph here of a ball of mass 20 grams moving along a straight line on a long table is given by this. How much force does the table exert on the ball to bring it to rest? So first we need to understand the graph. So at time t is equal to 0, what is the velocity of the ball?
Uh, 0.
At t is equal to 0, velocity of the ball is,
0.
no, it's not 0. At t is equal to 0, velocity is 20.
20. 20.
What is the velocity of the ball after 10 seconds? You can locate the coordinates, no? Coordinate geometry.
At 20.
After 10
Uh,
seconds, see, on x-axis we have time, right?
yes.
X coordinate will give you time, no? And y coordinates will give you the value of velocity.
Velocity.
You know how to write x and y coordinates? X
Yes.
coordinate is called abscissa and y coordinate is called
Um,
ordinate. So,
Ordinate.
yes. So the coordinates of this point is 0, 20, and coordinates of this point is 10 and 0. So x coordinate टाइम है और y coordinate जो है वो velocity है. तो when time is 10 seconds, velocity is 0, no? Because this point lies on the time axis. Its velocity is 0. And this point lies on the velocity axis.
Velocity axis.
Time is 0. And one more thing you can see here, that velocity is in centimeter per second. Unit of velocity is centimeter per second. It is not meter per second. It is centimeter per second.
Yes.
Okay. So x coordinate
Yes, ma'am.
at time t is equal to 0, velocity is 20 centimeter per second. And at time t is equal to 10 seconds, velocity is 0. Right? So how do we write the coordinates? We write first x coordinate and then y coordinate.
And then y
Yeah.
coordinate.
X coordinate gives time and y coordinate gives velocity. So these are the first coordinates that we have chosen. So this is your t1. We are writing time first and then we are writing velocity t1 v1. Why time first? Because time is on x-axis. We always write abscissa first, x coordinate first, and it is on x-axis. Time is on x-axis. So we'll write t1 v1.
Exactly.
And for this we can write t2 v2. See, because we have to find force. And force is mass into acceleration. Mass is given to us. It is 20 grams. No, but acceleration is not given. Acceleration we
Yes,
can
ma'am.
find out by finding the slope of VT graph. This we had done in the previous chapter. But acceleration is slope of VT graph. Velocity time graph का slope निकालने से acceleration आ जाता है. And how do we find the slope of VT graph? It's V2 minus V1 divided by T2 minus T1. This we had done in the previous chapter. A is equal to V2 minus V1 upon T2 minus T1. So put the values here. V2 is 0, V1 is 20, T2 is 10, T1 is 0. You will get acceleration negative. So minus 20 by 10, it is minus 2 meter per second, minus 2 centimeter per second square. Because velocity is in centimeter per second and hence our acceleration is in centimeter per second square. Right?
Yes, ma'am.
This is the unit of acceleration. And why are we getting negative acceleration? Because velocity is decreasing with time. You can see the slope is the graph is going down, no?
Yes, ma'am.
Yes.
So velocity is decreasing with time and hence acceleration is negative. And because we are getting a straight line here, so this is the graph of for uniform retardation. Acceleration is constantly, actually it is constant and it is uniformly retarding, we can say. Uniform retardation. Okay. Now, because centimeter
Yes.
we have here, we need to convert this into meter first. So how do we convert centimeter into meter? By multiplying it by 10 to the power minus 2 meter per second square. And mass is given. Mass is, it is 20 grams. If you look at this in the question, it is 20 grams. It is given to you. So mass is 20 grams and 20 grams in kilograms can be written as 20 upon 1000. No?
Yes, ma'am.
Kilogram, or we can write 2 into 10 raised to the power minus 2 kg as mass. Because we have to find force and force is mass into acceleration, right? It is mass into acceleration. Now put the values. Mass is 2 into 10 to the power minus 2 kg. This is your mass. And acceleration is minus 2 into 10 to the power minus 2 meter per second square. So force is 2 into minus 2 is minus 4 into 10 to the power minus 4 Newton. See, we can also write this in decimal. Minus 0.0004 Newton is the answer. Why are we getting a negative sign here?
Because it like force is negative.
Why is force negative? Because, see, what is this about? This is about a ball which is rolling on a table and it stops after some time. And why does the ball
Mm.
stop after rolling?
Mm.
The ball stops
Because there's
rolling
no
after
force.
the ball
There's
stops
no
rolling
force.
after some time because
Because there's no force. There's
there is a
no
force. See, listen to me.
like
There is a force which stops the ball. What kind of force is that?
um,
The ball stops rolling after some time because of the frictional force between the table and the
because
ball.
there's roughness in the
Yes,
table.
yes, that's because of the frictional force it stops
Because
after
there's
some
the
time.
table is not perfectly smooth.
Yes, if the table is like this and ball is rolling in this direction, then frictional force acts in the opposite direction, right, in which the ball
Hmm.
is rolling. So because it opposes the direction of motion, hence we have a negative sign here. Okay.
Okay.
All right, that's all for today. And tomorrow I'll take a German class. Please revise your concepts before coming to the class.